Our next speaker is Simon Griffith. He's an economist, geologist with over 26 years of mineral exploration experience with major mining companies in several commodities such as precious and base metal, uranium, nickel, diamond, coal, and coal bed methane, and in different countries such as North America, South America, Australia, Asia, and Africa, which are continent countries. He has supported as a geologist or geochemist discoveries such as La Herradura, Peñasquito, and Noche Buena in Mexico, and Resolution, Gold Rush, and Alturas in the USA and Chile. In the past 10 years, Simon has worked in Barrick as chief geochemist, and his current position is chief geologist in South America. Simon?
Thank you, Cirque. Yes, so the title of the talk today is Alturas, a unique discovery in a mature district through integrating sound geological practices, multidisciplinary expertise, and leading technology. I'd just like to point out I have some more co-authors on this paper. The team in Santiago, Daniel Astorga, Simon Cruzato, Carmina Jorquera, and Celia Plasencia. But we were just the ones who wrote the paper, and really the discovery was the fruit of a large team of people working on the deposit or on the project over several years. So I'd like to acknowledge all of their efforts as well. Do I have to point? Oh, yeah. So just a talk outline. By way of introduction, I'm going to talk about Barrick exploration objectives. Basically, what are we looking for? And then very quickly, a discovery overview. Then again, briefly, the project geology, just to set the scene. Then I'll get into the story of the discovery itself. And rather than go chronologically through the discovery process, I'm going to go by discipline. So we'll start off with talking about the geological mapping and logging, and the influence that had on the discovery process. The spectral geology and remote sensing, followed by the geochemistry, and then the geophysics. And then I've got a slide at the end just to wrap up and talk about, draw some conclusions. So, Barrick exploration objectives. Barrick exploration's main focus is to discover new core mines in the Americas. The core mines that Barrick operates, we aim to be basically break even at $1,000 per ounce gold. That's the economic metric that we use. And we aim to be the lowest cost senior gold producer with the largest reserve base with superior grade. So that's really the ethos that backs up our exploration activities. Some of the main, the main core mines that we do have, the Barrick Nevada operations was Cortez and Goldstrike, Pueblo Viejo there in the Dominican Republic, Lagunas Norte, which is in Peru, and we're JV'd in the Zaldivar copper deposit, but Veladero is the big mine there in Argentina. So just a quick overview of the discovery itself. I don't have such a good location map as the previous ones, but essentially La Serena was a city about a 6-hour drive north of Santiago, Chile, and the deposit is located in El Indio Belt there, which is essentially straddles the border between Chile and Argentina in the high Andes. This discovery is the culmination of over 30 years of integrated multidisciplinary geoscientific techniques. The El Indio Belt is defined by the overlap of two magmatic belts. It's the Eocene-Oligocene belt, which is coming down from the north, and the Miocene belt in the south. The geological and deposit type knowledge has evolved, and lessons learned have been applied to the exploration process over those 30 years. Modern, if we want to call it modern, or truly integrated exploration really commenced, though, only in 2010. This started with a belt-wide 1 to 25,000 geological mapping, which generated 2 kilometer spacing transects or cross-sections across the entire belt. So you end up with 40-something of these, 42 I think it was, of these cross-sections. We use remote sensing and regional magnetic surveys and geochronology of specific samples, which targeted geological mapping spectral, geochemical, and geophysical data acquisition. This resulted in subtle anomalies and being integrated into a conceptual concealed target. From the onset of drilling, innovative technology was incorporated, such as digital collection of geological data, core scanning, PXRF, optical televiewer, and all this resulted in a robust 3D model, geological model, which supported the delineation of a 6.8 million ounce inferred gold resource. The project Geology, basically the deposit is hosted, well, here's Alturas, and it's about 30 or so kilometers south of El Indio, which is one of the historic mines, one of the earliest discoveries in the El Indio belt for us, which was the one that was at the beginning of that 30-year exploration history. But anyway, Alturas itself is hosted in mid to late Miocene volcanics and volcanic clastic sequence, dacitic composition. And this geology basically defines a multiple coalescing phreomagmatic breccia centers and a diatreme complex, which is about 500 by 500 meters in size, which is this here. There's a 3 by 3 kilometer advanced argillic alteration zone, which starts off in the middle of the deposit or close to the gold mineralization as vuggy silica, as you can see a core photo there. And it's surrounded by a quartz alunite envelope, which looks a bit like this. Outboard of that, there's kaolinite, dicite, alunite with illite smectite assemblage, and which looks a bit like this in the drilling. And at the top of the deposit, in the shallowest part of the system, there's a steam-heated alteration, which is composed of microcrystalline quartz, alunite, and kaolinite, which we'll see later on in the talk. That's basically located here on top of the hill. Mineralization is associated with distinct silicification events. The upper parts are without gold and silver anomalism, except for one silicified cliff, which is exposed on the west side of the deposit, which is running about 1 to 3 gram gold, I think, the samples. So, the discovery itself. So the role that mapping and logging of the core played. We had a disciplined and phased exploration program, and Barrick does this in all of its exploration programs, essentially going from grassroots scale to target delineation scale through to drill testing. The evaluation of potential key indicators of a mineral system are looked for at all stages. During the grassroots, regional structural framework was assembled, and as we mentioned before, and then during target delineation, we identified or looked for evidence of high sulfidation mineralization, such as we looked for magmatic and phreomagmatic centers, we looked for typical sulfide and alteration mineral assemblages, and favorable erosional level. These deposits are formed fairly close to the surface, so the erosional level or the paleo surface is something that's quite an important factor. Drill testing and advanced exploration was supported by continued surface geological mapping and sampling, core logging, as we exposed more road cuts and drill pads. This resulted, like I said, as a recognition of a diatreme breccia complex with several phases of hydrothermal alteration. A series of plans and cross-sections resulted in a geological model focused on identifying controls on and the continuity of the gold mineralization. Key geological data were digitally captured using rugged portable computers and tablets in the field. Software that we incorporated or used was used to generate 2D and 3D geological maps and models. So a series of, you see here an example of some of the sections that we constructed through the deposits, through the deposit, and we'd also do level plans. Geochronology assisted in the compilation of stratigraphic column and to characterize the evolution of distinct volcanic events, the multiple advanced argillic alteration silicification events associated with mineralization. We also used optical televiewer, and that enabled the logging of orientated structures, which resulted in validation of the structural model and orientation of controls on mineralization, which also helped in optimizing the ongoing exploration program. Here's an example of an image you get from the televiewer. Requires a little bit of interpretation obviously by the geologist on which lines mean what in terms of faults and veins and fracture filling, and then you can plot all that data on the stereo nets. And it's a really good tool as well as being good for the interpretation of the geology. We used it to optimize the direction of the drilling. So the spectral geology. At the grassroots stage, alteration maps were generated from Probe 1 airborne hyperspectral data, and I think we heard that mentioned yesterday morning. This enabled the differentiation of potassium alunite from sodium alunite. Here we see an example of the sort of map or interpretive map you can get from the regional spectral data. Then we use portable hyperspectral instruments on the ground to validate the ASTER anomalies, which we also generated, and which generate then field-based alteration maps at different scale. The mineral composition vectors that we saw in alunite and illite, for example, showed that potassium alunite is a good indicator or a proxy to or a proximity to gold. And high aluminum illite is indicative or thought to be indicative of highly acidic conditions. The hyperspectral core scanning instrument was used in the core yard, so we set that up in the core yard and it was part of the logging workflow. This helped us to combine clay mineralogy with texture and mode of occurrence and assisted the interpretation of mineral paragenesis. Numerical logs that are generated contain mineral abundances and compositional crystallinity indices, and this was integrated with geology and geochemistry. This was used to create assist in creating the level plans and the 3D deposit models as we went through the discovery process. The spatial distribution of various alteration assemblies also assisted in an understanding of timing of these events. And on the right-hand side of the slide, I've got a sliver there of an example of some of the images you might get from the mineral maps, which comes from the core scan machine. And as you can see, we've got very good differentiation. We've got a few different phases that are shown here on this image, pyrophyllite and the sodium alunite and various other alteration phases, including jarosite and silica as well. So anyway, it helped us in the overall definition of this broad zoning from outside to in towards the deposit of kaolinite, aluminum illite, and silicification. So the geochemistry. A stream sediment survey was completed to complement the historic stream sediment surveys that we already had. The data were interpreted, consolidated, reinterpreted, and considering the structural domains and alteration ages, host rocks, and alteration types that were taken from the geological mapping and other sources. Gold results were not conclusive, though. Very, very subtle, if you want to call them that, gold anomalies. Rock chip sampling was critical in identifying a favorable horizon for mineralization. As I mentioned earlier, there's a gold-bearing outcrop. I don't know if you can quite distinguish all the red on this map, but the hatchet area is basically the area between two contours. It's approximately 4,850 meters above sea level. And the outcrops here, with these outcrop samples are the stars, and then the gold samples, or the samples that run more than a gram per ton gold. The big red outline is the surface projection of the grade thickness of the deposit. And these purple amoeba here are just the outline of some very, very subtle trace element anomalies. So gold bearing outcrop was the key thing. It gave us an idea of what the gold bearing or the mineralized horizon might be, the elevation of it, and so we had something to drill towards from the surface. So gold and pathfinder elements such as arsenic, antimony, and mercury and bismuth are very low. where the deposit is covered. But we used a study, or we actually did our own little study of the surface geochemistry above another barric high sulfidation system, and that was key to our understanding of the subtle concentrations of the volatiles above this deposit. It was before we drilled it. Then drill results showed that we had a barren cover of about 100 to 150 meters and over the center of the mineralized system. So these results, with information from the other disciplines, helped target future drilling. And the drill hole sampling procedures were then rapidly documented and developed, and we very early on in the project generated some project-specific or matrix-matched certified reference materials. These came at a actually very, very similar cost than it would have cost us to buy commercial ones. Multi-element data interpretation and modeling in 3D software. We integrated with spectral and geophysical data to further define discrete mineral pulses, and the sampling programs were ongoing along outcrops that were being newly generated and newly formed as we were building more roads and drill pads. And 3D geological geochemical multi-element models provided early indications of geometallurgical characteristics of the ore body and the waste rock. We also used mineral chemistry. It was applied. It was then ongoing research projects that we were funding or helping to sponsor. It turned out that alunite and quartz, when analyzed by laser ablation, ICP-MS, demonstrate the paragenesis of several alunite phases, which are consistent with the proximity to large high sulfidation deposit. Also, the quartz mineral chemistry suggested proximity to a large hydrothermal system. Geophysics. So early on in the program, we had airborne magnetic and satellite gravity, which extended throughout the belt. It helped us with the structural interpretation, which refined those and defined and refined those major block-bounding structures, which were used as a framework to interpret other things like the geochemistry. During the exploration, when we did more of the target delineation type work, we ran CSAMT surveys. A few early holes recognized two deep-rooted silicification centers. One of them was concentric and pervasive. It looked very, very pervasive, the alteration. So that was given, and it was also proximal to some mapped seam-heated alteration on the surface. So that made that particular CSAMT or resistive body look more attractive for initial drilling. Petrophysical measurements were collected using our in-house portable desktop laboratory on site, and additional CSAMT lines after we'd done the first few drill holes showed gold was coincident with several modes of silica. So really, probably the main thing on this graph is that you can see there's a quite nice resistor there in the sort of eastern side of that section. This is looking north, which corresponds with these nice looking gold intercepts down hole. And we've got alteration. The sort of mustardy color alteration down the holes is the silicification. On the west side, it doesn't work quite as well. We've got a lot of illite smectite alteration out here, so it sort of masks the resistors, look a little bit more conductive out there. So just to conclude then, the application and integration of diverse exploration technologies was led by geoscientists. The focus was on the detection and definition of key geological features, which allowed area reduction and vectoring towards ore. This suggested the presence of a phreomagmatic system with favorable alteration and high potential to host mineralized system. Drill results confirmed the predictive geology model under variable thickness of barren cover. The geological model focused on the understanding of main controls on mineralization. Economic parameters such as strip ratio and metallurgy were also estimated during the exploration process. Geological data capture, like I said before, led to validated geological model and an inferred resource calculated at 6.8 million ounces at a gram per ton gold. just very quickly print out. So this is basically just an illustration of the one of the models that we had. This is showing the alteration, and again, it's a similar cross-section looking north through the, or slice through the model. And you can see up here, if you look at the steam-heated alteration, this very light blue color, which is right on the top of the deposit. And really, these are the surface samples, or geochem samples, showing that really we had a few gold anomalies down here on the shoulder, but above where the main part of the deposit is absolutely, very, well, let's just say very, very subtle geochem. Anyway, so really the appropriate application of exploration techniques in a progressively scale-reducing, staged approach, in addition to incorporation of innovative technologies and best practices, has enabled the transformation of data to information and information to knowledge. The most significant aspect of the discovery has been the collaboration between diverse geoscientists. We have field geologists with continual support of highly qualified technical specialists and a discovery track record. This motivated us to collaborate in a robust, multidisciplinary, discovery-driven team. Thank you.